Hello, Intro to Proofs. This is section 3.2. Today is March 30th. It's been a long month. So we're gonna do preview activity 1 first. You should have attempted this, but hopefully you didn't try too long on this. So for this one, we're asked to find if n is an odd integer, then n squared is an odd integer. We proved that earlier, and now we're being asked to show if n squared is odd, then n is odd. Okay, so we look at we're given the beginning of a no-show table. So let's just make that here. So we've got p, that n squared is an odd integer. And then that's a hypothesis. Okay, and then we're given p1, and you've got, that means that there exists. What does it mean for n squared to be odd? There exists some other integer, call this one k, such that m squared equals 2k plus 1. So that's the definition of odd. Okay, and then lower down, we've got two statements here. We've got n is odd, which is what we hope to prove. That's our, and then we had the stuff right before that, because you break down that, there exists a q in the integers such that n equals 2q plus 1. So then this becomes definition. Okay, now last time we were able to use algebra to go from here to there, but this time we cannot. So think about it. Here, n squared equals 2k. Like, we need to get down to n. What's the only way to get down to n? I can either divide by n, but then I'm gonna have a fraction that I don't know anything about, or I can take the square root of both sides. Either way, if I try, let's go kind of down here. So we try the two ways I have to get n squared down to n would be square root or divide by n. So then if I take this n equals the square root of 2k plus 1, how do I get that to be 2q plus 1? It's a square root. You can't really get rid of a square root except to square it. Then what if I divide by n? N equals 2k plus 1 over n. How do I get that to be 2q plus 1? I've got n inside of that. That's trouble. So this is an example where the algebra really doesn't help you. There's not a good algebra connection there. However, let's go to, grab some more paper here. Preview activity 2. So preview activity 2 is the contrapositive. So this is you're being asked to complete a truth table that you've already done. But we'll do it again just for fun. So then we need P, Q, oh, that's incorrect. Q, true, 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 false, false, true, false, false. Then you've got not P, or not Q, and not P. Not P. P implies Q, and not Q implies not P. Complete that out. Okay, so opposite Q, well, that's false, true, false, true. Opposite P, well, that's false, false, true, true. P implies Q. Well, if they're both true, it's true. If P is true but Q is false, it's false. And then the other two are vacuously true. And then not P implies not Q. Well, if not Q is false, it's vacuously true. So I'll put those down first. If not P is true and not P is false, then the implication is false. And if not Q is true and not P is true, then it's a true statement. Look at that. They match. So they are the same. So this is called, again, I think we've already talked about this, but it's called a contrapositive, and it's worth knowing. Okay. So we completed that. Now, if we think about the statement we want to prove, we want to write the contrapositive of this statement. So not odd means even. So to say that instead of saying for each integer n, if n squared is odd, then n is odd. The contrapositive would be negate and swap the order. So that would be for each. Now notice I'm not negating the quantifier. I'm only negating the P implies Q. So for each integer n, if n is not odd, so if n is even, then n squared is even. Okay? So let's do a no-show table for this. I don't know if I have enough room. I think I'll need to switch to a new piece of paper. So we start off with P, and if n is even, n squared is even. Hypothesis. Okay. Now, I don't know exactly where there's a problem with using Sharpies instead of my usual dry erase markers. Maybe I'll make a little, I can use the whole piece of paper though, so I'll just make kind of I know what my ending looks like. So my ending looks like this. Q, so then, all right, the hypothesis is just if n is even. So P would be n is even. That's a hypothesis. And then the conclusion would be n squared is even. Okay? Oh, you can't see that. Okay, the conclusion is n squared is even. So then unpack this definition. So Q1 is that there exists a Q in the integers. I don't know why I keep using little q for this, but the book keeps using it too. It's a nice letter. You don't have to use little q. You can use whatever letter your little soul desires. All right. There exists an integer q such that n squared equals 2q. Okay, so then that's definition of even. All right, so then up here, n is even, so then unpack that definition. Means there exists a k in the integers such that n equals 2k. Okay. I should have done this in Microsoft Word, then I could have edited it. I still can't. Okay. Switching, because it'll look nicer this way. Okay, move me down here. Insert table, 3 wide. Make this narrower. E, and then N is no. N is even. Zoom in a little bit. Okay. And then we unpack the hypothesis, so that means, let's start our equation. Alt equals exists K in PDZ. I don't know if that's going to work. Oh dear. All right. Exists K in Z. Maybe I'll fix that later. Get anyway. There exists a K in the integers such that n equals 2k. That's definition of even. Okay, and then I've got my conclusion. Is n caret 2 space is even. And then I unpack that definition by saying alt equals exists q in Z such that n squared equals 2q. And so then here, if n equals 2k, I can say n alt equals n caret 2 squared equals, and then substitute. So 2k squared would be 4k squared, and that's substitution and algebra. Okay, and then that means that n squared equals 2 times, you know what, let's not do 2 steps at once. Let's do 2k squared, and it's just substitution. Okay, I can do my algebra right here. Equals 2 times 2k squared. 2 times 2k squared. And I need to insert table 2 layout, insert below. Then I can say 2 equals 2k squared. Is an integer by the closure of, this was algebra by the way, and then I need to have that there exists anymore. Say q, I don't even need this line. Delete row, letting q alt equals q equals 2k squared. All right, that completes preview activity 2.